So everything up to this point for the vector packet really is designed to get us through this problem. It's just a kind of a culminating exercise to see if we have everything. And if you were going to be asked to do something in class, it is going to be this. You are going to be, if I'm going to test to see whether you're doing this, I'm going to give you two vectors, say P and Q here, and I'm going to ask you to calculate for me a third vector that will completely cancel out these two. Okay. So what is that going to entail? Well, we first of all have to figure out the sum of these two. So the general idea here is to do the following. I would go through in this order. Let's see. Let's go here. Bring it down to like 16. So I would say the overall goal here is to, let's look at it this way. Here's what I would do first. I would sketch a graph. Showing this, the two vectors and their sum. So here we'll cut to this because I think it's easier for me to show it to you this way. So one trick that I like to do is this. You do the angle first. 67 degrees is going to be, line up our protractor here best we can, 10, 20, 30, 40, 50, 67 is about here, and then I got to keep the paper still because I'm off the paper. But I got this. It's going to be off in this direction. But how far? Well, this is a little trick I like to use. So in this case, I get an index card, and I decide, you know what, I'm going to make each one of these blocks 10. So it's 10, 20, 30, 40, 50, 60, 70, 80. That means 78 is about that far. So then I can take my card and I can line it up and mark off where about 78 is. So it's about there. Get rid of everything else. So there's vector P. Now, when I go to do vector Q, I'm going to do it off of that. So I'm going to take this and just sketch real quickly an x-axis and a y-axis. And now I'm going to measure my angle for a vector Q, so that's 115. Sorry, 115, that's not the angle. 342 is the angle, which is a reference angle of 18 degrees down here in the fourth quadrant. So I'm going to turn my protractor upside down, line it up as best I can, and really this is a sketch, so you probably won't even take as much care as I am, but since I'm teaching it, I feel the need to do that. So it's 10, 18 degrees is going to be about here. I'll just draw a general line in that direction, and then how far is 115? Well, I've marked it off on my card here, and it's going to be about here. Now, that means the resultant of the two, when I add the two, they act as one vector. I'll do this in a different color. They act as a vector, whoops, pointed like so. And we want to cancel that. So we want the opposite of this resultant. So if this is the resultant of those two, I want its opposite. I want a vector down in here. And the reason I sketch it is this. And in fact, I can just mark off real quick how far it is, just to get a feel. So it's in this. And it's 180 degrees the opposite way, so it's going to be to about here. So this is what I want, this vector here. This is the opposite of the result. And now I can kind of tell from my sketch, and the reason this sketch is important is I'm expecting an answer now in this third quadrant. If I get an answer somewhere else, and I'm also expecting an answer with a relatively large x component and a smaller y component. These are some things I keep in the back of my mind. Now, what are the steps to actually calculating it though? Because the picture is great. It's just there to make sure I don't make any silly mistakes. What about actually calculating it? Well, let's get a piece of paper and let's do that. So the next step in our process, after we make graphs, is going to be to actually add them up. And what we need to do is first, in order to add two vectors, you probably know this by now, right? We got to get them into their components. So we're going to add these two. The next thing I'm going to do is I am going to break them up into their components. So let's take care of that. I've got let's find it here. There it is. So I have vector P, which is this 78 at an angle of 67. So I'm going to break those into components by taking 78 times, now what's going to be my x component? It's a cosine, right? So times 67 cosine equals. So vector P has an x component of positive 30.477. I'm going to take some decimals out on this one. That's my x component. And then my y component for vector P is going to be 78 times the sine of 67. Don't forget to hit equals. So 71.799. Positive 71.799. That's my y component. Both positive. Not surprising, it's in the first quadrant. Now, vector Q is all the way down the fourth quadrant, so I would expect a different set of signs. So Q, notice how I write them underneath of each other here. So Q is going to be 150, its x component I should say, 115 times 342 cosine equals 109.371. So positive 109.371 is my x component. Positive makes sense? Yeah, because that vector would go in the fourth quadrant, so that's a positive x. Let's see if we get a negative y. So I'm going to do 115 for the y component times 342 sine, notice the sine's negative, equals negative 35.537. Negative 35.537 is my y component. So now I have the exact same two vectors that I had before, except now I have them in their component form. And to add two vectors in component form is very straightforward. I just combine these. So in this case, I would take 30.477 plus 109.371, and I would get a positive 139.848 as an x component. And then my y component, I would do 71.799 minus, because this one's negative, 35.537. And I get a positive 36.262 as my y component. And I just double check, when I added these, I did get something in that first quadrant, and I do notice that the x is bigger than the y, so it makes sense. I could go as far as to really check, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, almost, wow, that's pretty good. 139, that's not bad. Almost 140. And then 10, 20, 30, 40, a little under 40. That makes sense. So we're in the right ballpark. This is the resultant vector, the sum of the two. But it is not the vector that will cancel them. It is just their sum. We need to cancel this vector. So we need the opposite of it. And the easiest way to find the opposite is right here in this step, and that's to switch the signs. So if they're positive, make them negative, and if they're negative, make them positive. In this case, they're both positive, so we'll make them both negative. 139, so negative 139.848x minus 36.262y. And it's at this point that it's good to notice what quadrant you're going to be in. That's the significance of these negatives. Since these are both negative, I know I'm in the third quadrant. At this point, I'm going to put it back into magnitude angle form. I'm actually going to ignore the negatives for a while, but I'm not going to forget, make a little note to myself, that I have to put it back into the third quadrant. Now let's do this real quick. So when we go back here, I'm going to point out, so break them into the components, add the vectors, find, let's go add the vectors to get the resultant. R. Switch signs on components of R to get the opposite of R. Find the magnitude and angle of the opposite of R. Now that's a process we've done earlier. So we're going to go through that now. First part is the Pythagorean theorem. The magnitude of the opposite of R, remember I dropped the negatives here, is going to be the square root of 139.848 squared plus 36.262 squared. So I got 139.848 squared plus 36.262 squared equals, then take the square root, and I get 144.473. So the magnitude of that vector is 144.473 units. And now I'm going to get the reference angle. Remember, the reference angle is going to be the inverse tangent of the y component, right? Negative r's y component over negative r's x component, the opposite of r's. But remember, I really don't care about, this just means opposite of. It doesn't actually mean they have to be negative. And in fact, I don't really care about the negatives. So in this case, the reference angle is going to be the inverse tangent of 36.262 divided by 139.848. So I grab my calculator and I go 36.262 divided by 139.848. Then I do second tangent, and it gives me an angle of 14.5 degrees, we'll say. So the reference angle is 14.5 degrees. Check my sketch. Does that make sense? Does that look like 14.5 degrees? Well, there's one way to find out. Yeah, I'm liking it. It's pretty darn close. Now, we gotta make a note. That's the third quadrant, though. So our final answer is going to be the vector that will cancel out the two that we were given, the P and the Q. So here's our two given ones. The vector that will cancel that out is going to be 144.473 units in magnitude at an angle of 14.5 degrees in the third quadrant. Or, if you'd like, 180 plus 14.5, you could write it as 144.473 at 194.5 degrees. And you wouldn't need to say the third quadrant because that would automatically indicate that you were all the way here. All right, it's a multi-step process. We built you up to this point. It's worth it to practice a few times because, like I said, if you can do this, then you prove to me that you did the entire vector part of the summer assignment. Thank you for your attention and practice some.